Hey there, Gregory Carlson here with the Calculus Building. So what would the derivative of a linear function be? So say I have some function f of x is equal to m times x. And so what would the derivative, the slope everywhere, what would that be? Well, you know hopefully that if I have a function like m times x, then that would be just a line going through the origin with a slope of m. And so that's what the function would look like. What this slope might be positive or negative. And so the question is, what would the derivative be? And since this line has a slope of m everywhere, the derivative should just equal m, because that's the slope of the line. So let's use the definition to show that. The limit as h goes to 0 of f of x plus h minus f of x all over h. So let's plug in our functions. So f of x is equal to m times x. So that means that f of x plus h would be m times x plus h. Okay. Then we would subtract f of x, which is just mx. And all of that is divided by h with our limit as h goes to 0. Okay. So if I do the distributive property right here, I would get mx times mx plus mh right there after the distributive property. And you can see that negative mx would cancel with mx. And so basically all I get is m times h on the top all over h on the bottom, because that was the only thing that remained on the top was the mh. And so now before I take the limit, you can see that my two h's cancel. So I take the limit as h goes to 0 of just m, and the limit of a constant number as some other value goes to 0 is just going to be the value. So you can see that the derivative of this function is going to equal m. So let's look at two examples really quickly. Let's say I have f of x is equal to 13x. Well, I can do the derivative in one step thanks to that rule we just showed. F prime of x would just equal 13. So that's pretty easy. How about a slightly more complicated one? F of x is equal to negative 2/3 x plus 9. So what would be the derivative, what would be the derivative of the function negative 2/3 x plus 9? Well, now we're going to use the addition rule that we did earlier on. And because remember, I have two functions being added, so I can just take the derivatives of them separately and then add those back together. Now we know that the derivative of a constant is just 0, so that wouldn't have any contribution. And the derivative of negative 2/3 x, well, that would just equal negative 2/3 because of the rule we just showed. So that's really important. And so what that means is if you have a line, the y-intercept doesn't have an effect on the derivative. And that should make sense because if we have a line graph, if we shift it up or down, it doesn't affect the slope. The slope is still going to be the same. Whether the line crosses at plus 20 or whether the line crosses at negative 5, it would still, that change wouldn't affect the derivative, which is the slope of the line. So hopefully it makes sense that the derivative of a linear function, the constant would not matter, and it would just be the slope that's being multiplied by x. In the next video, we're going to look at a really, really powerful idea called the power rule. And when we see that, I think you're going to really appreciate the power of the derivative even more. See you there.